Welcome everyone to APCS Principles. Okay, my name is Daniel Kim, and I'll do an introduction of of this course, and we'll get into the lectures. Okay, so let me just talk about a little bit about myself. Well, so that you can trust me, I have a PhD in engineering with some field experience, and I have about more than 10 years of experience with coding. And actually, back in the days when I was a student, I took what's right now APCS-A, okay? But I didn't have the chance to take the APCS-P because I was already too old when it first started. I am currently the main computer science, math, and science instructor at one of the biggest institutes in Apgujeong, Seoul, just in case you don't know where that is. Okay, and I have done comprehensive analysis of all of the question types that appear on the exam since its first exam in 2016. And this current course will cover the absolute essentials that's required for you to get a 5, okay? So all of the things that I talk about throughout the lectures, they are going to be asked in some way on the exam, okay? So you need to remember all of those concepts. And, well, my results, like APCS-P is actually one of the hardest subjects to get a 5 on the exam. Like the distribution of a 5 is about only 10%, which is one of the lowest, and combining that with a 4, that's also like 35%. But over the past years, my 4 to 5 ratio has been at 92%. So I've proven that, that kind of says it all, right? Okay, and also I have developed my own websites and platforms for you guys to take advantage of. So like I have my own website, which I'll attach the link to the course description. So if you go on there, you'll see all of the resources that I'm providing. So you'll see some coding platform, this APCS notebook. We're going to be using that when we're doing coding exercises to prepare for create performance task, and AP Prep Studio. This is like flashcard or problem sets that you can solve, like also on your mobile, regarding the concepts covered on the exam. And I do have some textbooks released on Amazon as well. All right, so let's talk about I guess that's enough of me. Let's talk about computer science. This course is called APCS Principles, okay? So we look at the bigger picture than just coding, okay? Also, create performance task, we're going to be doing some coding, but on the MCQ exam, you need to just interpret what the codes are for. How does the internet actually work? How do we secure data? How does technology impact society? So these are some of the bigger pictures that we are also going to be looking at, which is actually these are all major fields in computer science if you look at it as a whole. Okay, programming is just one tool we use to solve these broader problems. And why should you study computer science? Like these days, I get a lot of these questions. Wait, isn't computer science losing its popularity? Well, that's not true. It's actually true, but I do have some reasons. Okay, the hype for coding fluctuates. Yeah, during the COVID, there was an explosive demand for programmers, but after COVID, right? But computer science, you can always think of it as it's now a requirement for other major subjects. Computer science itself, it's still very, I think it has a very good potential because the AI boom is going to require even more proficient programmers to develop these AIs. The AIs will do the coding for us, which I'm going to talk about in a bit. But anyways, computer science is now a requirement for most major fields. Just because you're not studying computer science doesn't mean you'll never use it. Now, if you look at biology, you need computer science to map genomes and simulate ecosystems, right? When you do simulations, these are all computer science. And in history, you need computer science to visualize timelines and analyze sociological data trends, okay? So you might think if you major in history, you're not going to deal with any kind of data analysis. You're wrong. Actually, a lot of history is about analyzing the historical data, okay? And finance, yeah, it's pretty obvious, right? You need code to build algorithmic training models. Like if you're a professional trader, then yeah, even more so. And yeah, let's get into the AI revolution, which has been a lot of, what a lot of people have been concerned about. Computer science is a must-have skill in the modern world. Even if the AI is booming, okay, we need it even more. Okay, so especially with the recent AI boom, understanding how these systems work is critical. So you cannot maximize the use of AI if you don't understand the underlying principles. So let me talk about the website that I developed. That website, I developed it with AI. Okay, but in the process, I also realized, like before that, I also had some doubts, okay? But when I made that website, I was certain that, there's still going to be growing demand for computer science, because without the basic knowledge in computer science, you cannot build that website. You need to instruct specifically the AI what kind of functions you need. What AIs can do is when you tell it to create something, it will create something that is more common, okay? That is more popular, more common, something that you can frequently see on like other websites. But when you want like killer features, when you want specific features, functions, you need to tell the AIs what you specifically need. So that's one. Two, you need to debug this process. Of course the AI can debug, meaning fix errors in the code if something isn't working right. But it's also about the money. The AI sometimes cannot fix that specifically to your needs. So what I did was I manually went through the code to identify where I want to revise things and told it to the AI, and it was a much more efficient process. Okay, so just because AI is evolving does not mean that coding skills or computer science skills is no longer required. It will actually, to maximize productivity, it's actually going to be more demanded. All right, so now let's move on to the actual exam. So just in case you guys don't know this yet, the exam is it's kind of divided into 3 parts, but 2 main parts, okay? So first we have what's called create performance task. This is where you create a simple program following the rubric, and then you submit it at the end of April. It was usually the last week of April always. So yeah, what you need to submit is program code and a short video of you running the program. And this number 2, written response, it was originally handed in along with the code, but it's changed because of AI. Like a lot of people were just using AI to submit it. So they actually changed it to a free response section on the exam. So here, now you only submit the program code and video at the end of April. On the test day, you have 2 sections now. So first section is going to be multiple choice questions, which are 70 questions in 120 minutes, which is worth 70% of your score. And the written response, you have an hour, you answer prompts about your code. So this written response will have questions that will ask about specific parts of your code. So it's specifically designed in a way so that if you didn't write that code by yourself, you won't be able to answer these questions. So that's why I go through like Python and Java code, fundamentals, and later on I provide like a template that you can use that meets all of the criteria, and and the structure there is pretty simple for anyone to kind of understand, explain what the code is doing. Okay, so There are 5 big units in an AP CSP. So they're called Big Ideas. So Big Idea 1 is creative development, where we talk about like leadership, communication, and participation, collaboration. And 2 is about data. That's for like data science field in computer science. So we talk about like binary code and what these different types of data is, how data is saved on your computer. And number 3 is algorithms and programming. Here, you need to interpret some code, but that code is actually not like Python or Java, but it's going to be like a language neutral language that College Board came up specifically for the exam. And number 4, big idea 4 is computer systems and networks. We talk about the internet, the networks, how things are connected over the network. And big idea 5, it's the social impact of computing. So what kind of impact has evolutions in computer science brought to the society? Okay. And also just a few advice before we get started. While we're going to learn some coding, Python and Java or Java, the logic is more important than the grammar or the syntax. So you must learn to think like a computer, breaking down complex problems into small logical steps. So what I'm saying is, do not memorize, like when you see a code, do not memorize the code line by line. That will never help you. I mean, I will explain on the way, but no 2 codes are going to be written exactly the same. Okay? It's always going to be different. So memorizing the code is going to be completely useless for you to get a 5 on the exam. You need to understand the logic, how it works. Okay? Like when you write an essay, you're not going to produce 2 identical essays. Okay? So it's going to be different in some way, right? Similar with the code. You'll never get the same exact code on the exam. So you need to understand the logic. Okay? So the exam will test your ability to trace algorithms and predict outcomes regardless of the specific program language used. Also, it's not dependent on any kind of language. Okay? Again, it's language neutral. All right, and memorizing definitions is not enough. You need 100% conceptual familiarity, meaning many MCQ questions on the AP CSP. This is why it makes it really hard to get a 5 on this exam, because the questions, most of the questions are like case studies. They give you cases, and the options, they are examples of the concepts. So they don't directly ask you, hey, what is an algorithm? Okay, so they'll ask like, hey, what's wrong? What could go wrong if you write an algorithm in this way? And then they give you like examples, and then you need to choose the answers. So just memorizing the concepts again will not be enough to get a 5. You need to understand the concepts. And that's why I always recommend my students to develop their tech literacy, meaning apart from studying all of the concepts involved with the curriculum, you also need to think of it as like keep being updated with current events. Okay, so to get a 5, you need intuition about the modern tech. So you need to stay updated with recent trends. Okay, hardware, industry. So so that means you need to read the news about what's going on in the tech world. Okay. And like YouTube, there are a lot of YouTubers who introduce like new tech, new gadgets, or like new AI model, like what you can do with that AI model. So you need to get in the habit of watching these videos or reading the news, okay? And that, trust me, that will make it a lot easier for you to get a 5. So like I saw you, only 10% gets a 5. And if you don't do this, it's going to be hard for you to become one of the 10%. But if you do, it'll be easy, okay? So this general knowledge towards the tech industry and computer is very crucial in getting a 5. All right, so this is how this series is organized. So all videos are divided by College Board's Big Ideas. So if you look at the organization, I have the Python Java lectures in between Big Ideas 2 and 3. The reason why it's designed this way is if you watch the Python and Java lectures first, that actually makes it very easy to understand Big Idea 3. But if it's the other way around, it's kind of hard because you first learn a language that technically doesn't exist, and then you actually learn the actual language. That process is actually, it turned out to be a lot harder for students. So I have organize it this way. But if you prefer to watch 1, 2, 3, 4, 5 and then go to Python, Java lectures, then it's completely fine. Okay. All right. And also for Python and Java videos, we'll be working on a platform created by me. It's called APCS Notebook. And then you need class code to access all of the modules, meaning all of the exercises. So remember to enter this code. If you watch the first coding exercise video, I do explain how you can access these. So and you need to remember these code and then enter it as you join the class. Okay. All right. So I think I've done. Whoa, it's been a long. Well, yeah, this is gonna be a longer video than I thought. So I think I've introduced enough. So let's get right into the main content. And trust me, if you listen to all my advice and follow me for until May, then I will guarantee you a 5. Okay. So just follow me. Okay. All right. So let's get right into it, guys. I'll see you in the next video. Okay, everyone, now let's look at program design and development. So before we looked at, the process, like the input, the processing, and the output. Now let's look at some of the general common form of how we develop, design and develop our programs. And it's gonna be pretty straightforward. It's gonna make sense. There's nothing really complex about it. If you look at the process, it will make sense. Okay, so let's take a look. So why does design matter? Like, those MBTIs, like if you're a P, then you say you're not really good at designing and planning. But regardless of whether you're P or not, this process is a must-needed process here. So designing. So would you build a house without a plan? You just, are you going to just build it brick by brick and then just build it as you go? No, right? So the same thing applies to programs. So a good program design saves time and effort. It makes programs easier to understand, helps identify problems early, creates better user experiences, and it reduces bugs and errors. So again, you're not going to be the one using the apps. There are other users. The public is going to be using your apps. So again, you need to plan this ahead of time, clearly identify what their needs are, and clearly design how you're going to solve those needs. So in this topic, you'll learn how developers create programs using iterative, user-focused design process and also incremental process as well. So there are the types of development processes. So development processes can be ordered and intentional, follow specific steps in sequence, planned and structured. An example will be what's called a waterfall model. And number 2, exploratory in nature. It's more flexible and adaptive. Experiment and discover. Try different approaches. This does not mean that you just build brick by brick, okay, without any planning. So you plan one stage, and then after you finish, you think about what you need next, okay? So that's what it means. So there are 4 development phases, and most development processes include investigating and reflecting, so researching the problem and the users, designing, planning how the programs will work. Number 3, prototyping, meaning you build a working version, so like a preliminary version of your app, and you test and you check if it works correctly. If it doesn't, you go back and then you kind of redesign it again and then solve the issues. So usually this is what we call an incremental iterative cycle model. Incremental will come up later. This is called iterative cycle model, meaning the 4 phases that I talked about, it usually goes, it repeats and repeats. What does that mean? So you investigate, reflect, you design, you create a prototype, and you test. Then, after receiving feedbacks from the test, you go back and then you investigate and reflect again on the feedbacks, and then you design what you need to fix, and then you prototype again, you test, and you repeat this process until it becomes enough, okay? Well, but what does iterative mean? It's a word used very often in computer science. It means repetition, basically. So iterative means repeating a process to make improvements in this context. So development is iterative because you don't get it perfect the first time. Again, no matter like how big of a project you're working on, okay? On your first version, it's not going to be perfect, okay? So you don't get it perfect the first time. Your test is going to reveal obviously some problems, even though you feel very confident that, okay, so my program will not have any issues. But when you test it, you're a lot of the times, you know, just problems are going to be popping out from where you didn't expect. And feedback suggests improvements, and you may need to revisit earlier phases. So you test, you find bug, you go back, fix, test again. So this is this is an example of an iterative process. And also, like I mentioned in the beginning, I do have some websites and apps running for my classes. And yeah, this is what I did in the earlier phases. Like I took some of my students and then suggested that they try out the apps. And yeah, like I also thought that there won't be any issues or any problems. But yeah, as the students used it, there were just like problems popping up from everywhere. Like one example was, you know, like as the students wrote the code, like sometimes, like when you start typing, sometimes like it will jump to like a new line, and then like you'll start typing there. Like it just made that random jumps, and like that didn't happen while I was testing myself. And that started happening when students were testing it. And, you know, the issue was from somewhere completely unexpected. Like, it was from, like, an autosave feature. So, as it autosaved, like, the code I had in the background, like, I refreshed the code. So, it wasn't intentional, but, like, it refreshed the code every time. And that's why it caused those random jumps, for example. So, again, you don't know where your problems are going to be, where the problems are going to come from. So, you need to be able to test. You need to test it before you launch it. Okay, so that's a very important principle. Okay, so let's get into it in a little more details. Phase 1, investigating and reflecting. So, like, you have to understand the problem or the task that you're trying to tackle. So key questions to ask would be like, what problems are we solving? Who will use this program? What do the users need? What features are most important? And are there any similar programs? So example here, creating a study app for students. So what study methods work? So users will be high school or college students. Their needs are flashcards, timers, and progress checking. So you need to be able to here are like the needs. You won't be able to figure that out like right off the bat either. So like you have to talk to the students, you have to do interviews, or you do surveys. Like if you're really immersed in like creating apps like this, okay? So again, how to investigate user needs? Surveys, you collect data. User testing, you watch people use similar programs. Like if you're not going to have your own version, but if you want to create like an app of your own, then you ask some people to use the similar programs and then kind of receive feedback. So what do you think will make that better? You know, like, and then you can differentiate your product depending on their feedback from using similar products, for example. And interviews, you have conversations to understand the needs deeply, okay? And direct observations. Watch how people currently solve the problem. Okay. Now that's phase 1. Once you figure out the needs of the users, you move on to phase 2, designing. So this is where you plan your program. So the design phase outlines how to accomplish your program specification. So what you need to do here is you brainstorm ideas. How can I tackle this? So you plan, you write what's storyboarding. Storyboarding is actually a very important thing. Like basically, you walk through the entire process of what your program is going to look like, and then you describe each step, and then you draw the UIs and the outputs and everything. Organizing programs into modules, creating user interface diagrams, developing testing strategy, and yeah, there are a lot of designing tools like Adobe XD that allows you to design your app and do all of these. So again, this is a very necessary phase. So a good design makes it a better program. So like UI, UX also, like UI, UX developers, they also get paid pretty good amount of money because it's actually very important, and a lot of companies actually spend a lot of money into these UI developments because it's how you are going to interact with the users. It's what the users are going to see about your product. Like when they open the app, they're going to look at the interface. So it's like the first frontier line of interacting with your users. So it's actually a very important component. And yes, it's very and not just those like physical designs, also what's underneath, that also counts as a design. So yeah, so good design means a better program. So we need to talk about a few things that are involved in this step. So program requirements. It's description of how a program functions. So, all right, guys, now let's get started on big idea 2, data. So a lot of computer science is, well, I would consider that everything about computer science is about data, right? So like even if you're playing games, I think I mentioned it before in the previous lecture that, just pressing the keys to move a character in a game, for example, that's also manipulating the data behind the scenes, like the coordinate data of the character. Like when we have like complex like calculator program, for example, then everything behind the scenes is about data, right? We put in a number, we do calculations, and we manipulate that data. So everything in computer science can be considered that it's about data. So, but first we need to understand how this data actually work on the computer. So first thing, we need to know about binary numbers. So computers represent data differently than how we see it. Okay, so programs translate data between internal computer representation. So that is binary code. Okay, and human readable formats, text, images, and numbers. And this translation allows us to interact with computers naturally. So we did mention it, right? We write code that is like in Python or Java or whatever, that's similar to human language. And the compilers, they translate that to binary code, and the computer recognizes these binary code, right? So computers are physical hardware devices that work with electricity. That's why they need to use binary. So like we see the numbers as zeros and ones, but zeros and ones are actually sequences of electric signals that's going into the computer. So at the hardware level, computers use electronic circuits, and circuits can detect 2 states, electricity flowing or not flowing. And these states are represented as high voltage or low voltage. And when we actually get into it in a little more details, like how these conductors are, placed, how they're arranged, kind of changes how the electricity flows through them. And, there are a lot of, like when you actually get into this microscopic level, it gets very complex. But this is like the general idea that is fine, okay? So binary is perfect for electronics. So when it's 1, high voltage is going through, so electricity is considered to be on. And when it's 0, there's a low voltage flowing through. So it's considered that electricity is off, right? So think of it like a light switch. So when the switch is on, it's 1, electricity is flowing. But when it's off, it's 0, so light is off, okay? And, why don't we use more digits? Well, again, zeros and ones are very simple when we're trying to deliver a signal using electricity, so on or off, right? But and if we have numbers 0 to 9, it's actually difficult to distinguish between 10 different voltage levels. Electronic signals can be affected by interference. Two states are simple, reliable, and easy to detect. So again, it's simple, only two states to recognize. It's reliable. There's a clear difference between on and off. It's fast, quick to detect and process. It's also robust. It's less prone to errors from electrical noise. I mean, because if we have like 10 different levels of electrical voltage levels, then it will just kind of mess things up a little bit. So now let's get into the actual units of data. So a bit is the smallest unit of data in computer science. So a bit, we call it's short for binary digits, so BIT. So it can only have two values, zeros or ones, and everything in the computer is made of bits, right? Because it's all zeros and ones. So again, think of it like a light switch. 0 is off, 1 is on. So all data is ultimately stored as patterns of zeros and ones. Okay. So even an image can be interpreted into pixels, and then these pixel data are then further translated into binary data, and ultimately that image will be saved in the computer as a series of zeros and ones that represent those pixel values. And the next is a byte. Well, a bit is very small, right? So we usually use bytes as the smallest unit to represent how big like a file is. For example, megabyte, a kilobyte, terabyte. That byte at the end, it's like meters, right? Centimeters, kilometers. So a byte is a group of 8 bits. So 8 digits of binary numbers. So you can think of 1 bit as 1 digit of binary number, and a byte will be 8 of these bits, so 8 digits. So 1 byte is equal to 8 bits. Each bit position can be 0 or 1, and this gives 2 to the power of 8, so 256 possible combinations. Okay. So 1 byte can represent a single character, a letter, or 1 byte can represent a number from 0 to 255. So because there are 256 possible combinations, actually you need to know that, okay? So it's 0 to 255, not 256, because we're starting from 0, okay? More than often students get that confused. So it's 0 to 255. And file sizes are measured in bytes. So kilobytes, megabytes, gigabytes, terabytes. Okay. All right. And what is abstraction in data? Abstraction is a very important concept, again, that appears here and there throughout computer science. And depending on context, like specifically, it can be talking about a little bit different things. But on the general picture, in the general idea, is the same. So reducing complexity by focusing on the main idea. Okay. So abstraction here means, it's hiding unnecessary details, or, showing only relevant information, or grouping related concepts together. So mostly we use abstraction to cover the first point, like hiding unnecessary details. So later on, as we get to coding, like we're gonna actually writing codes and algorithms, we're gonna look at it in more details. But like there are few like methods or functions that are there by default. And for example, one in Python is print method. So we print whatever comes inside that parentheses, but we don't need to know how it actually prints that value to our screen. Like whatever happens behind the scenes, we don't need to know about. And that concept is called abstraction, okay? Like if we put in a number on a calculator, we don't need to know how the calculator does that, right? We just worry about how we put in the numbers and what output we get, okay? So another example, simple one is when you see a number 5 on your screen, Well, what's behind the scenes is the binary representation, the electric signals going into the computer, but all we see is a 5 and we understand. We don't need to know what happens behind the scenes. And that concept is abstraction. So here we're actually going into abstraction a little bit because we're trying to understand how it works. But anyways, bits are grouped to represent abstractions like numbers, characters, colors, RGBs for red, green, blue values, images, sounds, and instructions. So abstraction allows us to work with complex data without worrying about the underlying binary representation. So here, all of these can be converted to binary code, right? So, but we don't need to actually know what that binary code to work with it. And abstraction is what allows us to do that. Right. But we do need to know how to convert between binary numbers and decimal numbers for the exam. But normally when we're using the computer, we don't need to worry about it. Different number systems use different bases. So our number system is called the decimal system, meaning it's not like decimal numbers, like point to something, 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 but the name of the system itself is a decimal system with a base of 10, meaning we represent all numbers possible using 10 numbers, so 0 to 9. So if you think about it, yeah, we can represent every single number with that, okay? So this is what humans typically use. Okay, everyone, let's get started on our first coding exercise. So, like I mentioned in the videos, that we're going to be using the platform that I created, and it's called APCS Notebook. So, you can just type in apcsnotebook.com or come and search on Google APCS Notebook. I'm going to walk you through the whole process. So, if you click on it, you'll land on this page. Click on Get Started, and then it will prompt you to log in. Yeah, and then you choose either Google or whatever account that you're using. So once you do, you'll land on this page. Okay, so you'll see the Welcome to APCS Notebook, and you do need to join the class. Okay, through my class code. So here on top of the page, click on Join Class, and you will be able to type in the code that will be provided by Master Prep. So, was that 2? Yeah, it was 2. So, DPF, sorry. 6x2. Yeah, and then it says successfully joined APCSP Master Prep. The name might change. I don't like the formatting here, so I might change the name, but the code will stay the same, okay? So here I'll go to my classes. So you won't see all the assignments here yet. Okay, you do need to go to my classes, click on view homework, and you'll see module 1, right? All of the other modules will be uploaded. So here, press on start, and you'll land on this page. So this is where you'll be coding, and as you can see, it's in if you know what Jupyter Notebook is, this is in Jupyter Notebook style. Yeah, you can change the font, you can change it to light mode or dark mode, up to you. And yeah, one of the good things about advantage of using this is you can write your notes, okay, and messages. And instead of just writing them as comments, you can literally write these instructions, and you can also write your own notes. You can create your own cells here, either in Markdown or in Python. Yeah, and one of the reasons why I developed this is, of course, I can manage my classes, but it was because of my APCSA course. I wanted a notebook like this for Java because APCSA is in Java, and yeah, I ended up creating this, and I also created it for Python. So, and also when you first run this, so let's run our first Python shell, and this is what you'll get, okay? But when you first run this, if it's your first time, it might take less than a minute though. It might take some time to run, so just give it a second, and then it will give you this output, okay? So now that was just running it, so that was 1.1. So let's go to 1.2. Multiple print statement. So here, these are some simple exercises. So if you know these already, you can skip and go to the later ones. But yeah, I'm just gonna show you all of them one by one. Okay, so yeah, so here's print separate messages. So here you can do print, and literally all of them, just in order. Welcome to Python. And you can do all of this in just one single shell, right? So make sure that all of these are put in the quotation marks. If you don't, here's what will happen. Let's just say, if you don't write something in quotation marks, if you try to run it, you will get an error. Okay, so here, and also don't be afraid of error messages. Don't panic. Like fixing the errors is all part of the process. Okay, so just write the 3 statements in the parentheses. Let's get started. Okay, and run that shell, and then you'll see the output correctly. Okay, now adding comments. So here, this, like, literally write your code here. That will be our comment, right? So here, we need to copy over the code. Yeah, just copy paste here, and then let's look at these. So we need to add in some comments. So we can do like first message, and then second message. Let's just do something simple. Third message. And like I mentioned, Python doesn't look at those comments. It just ignores it. Those comments are for the programmers only. Okay, so if we run this, we'll see 3 same output as before. The comments do not affect our outputs. Okay, now we printed the text values as print numerical values. So here are print 42. And then print 3.14. The types don't matter. Like, we don't need to do anything regarding the types. Okay, just put in the values here and run them, and then it will print the outputs for you like this. Okay. All right, now variables and data types. So exercise 2.1, creating variables. So create the following variables: age, okay, and assign value 16. So here, it will be age is equal to 16. Height is equal to 5.8. Name is equal to Alex. Is student underscore is equal to true. I think this is a good time to show you, like, what happens if you use like other symbols. Like, let's say you use a dash. Let's see what happens. Yeah, it gives you an error, and here, invalid syntax, right? Syntax means you have made a grammatical error. So yeah, as you can see, using a symbol other than underscore in variable names gives you an error. Okay, so that gets rid of that. Now just print. So print age, print height, print name, print is student. So if you just run it, it prints all the values saved in those variables, right? Okay, now data types. Like, I didn't explain this in the lecture, but like, we don't really have to do this a lot, but it does help when you get kind of stuck in errors and you need to check the data types of a variable. So it's the type function. So literally, type. Okay, so like 15, for example. That is a function that gives you the type of a variable. Now, we got to print that, right? So we got to put that inside the print function. So let's do that. And then it will tell you that 15 is an integer. We can try it with other types. So we can do 15.0. It gives you a float. Okay, and then maybe just use like true. Okay, it gives you bool for boolean. Okay, now let's go to 2.3, variable reassignment. Like we said, we just reassign the values to the variables. We don't need to worry about, other data types or anything. Here, so score equals 85. And then print score. So here, that will print 85 for us, right? Now, we can just reassign the values. So just do the same thing here. And then if we print that, it prints 92. What happens if we make that into a float? Doesn't matter. It reassigns the data type as well. Okay, so yep. So let's go to 2.4. All right, so multiple assignments. Like we saw before, we can assign variables to the same value all on one line, or we can assign multiple values to individual variables on one line like this. And we said these values will be assigned to variables in the respective position. So x will be 10, y will be 20, z will be 30. So we can print them out and see. Okay, let's just use this and see. Yeah, so it's been printed correctly. 10, 20. Oh. Let's actually do this. We have to, sorry, I made a mistake here. It needs to be x comma y comma z is equal to, not equals. So if we try this, now it should just print once. Okay, good. All right, so 10, 20, and 30. So when we are assigning the same number to these. Hello everyone, we're done with Module 4 and now we're going to move on to Module 5, Strings in Depth. So until now we looked at the fundamental control statements that will allow us to control our code, the sequence of our code. Now we're going to get into things in a little more in depth. Okay, so the first one we're going to look at is string. Okay, and strings we looked at it, but we learned how to take in string inputs and then print the output and concatenate. But those are pretty much it, right? But there's so much more than that with strings in Python or in computer science in general, because like a lot of the data that we deal with in computer science is going to be a string type, and we need to know how to clean, process these data so that we can actually use them for meaningful analysis. So let's get into it. So the first 5.1 is going to be string manipulation. So why do we need to learn string methods? So again, strings are everywhere in programming. So we process user input. That's mostly what you're going to be doing. Validating data. So we need to validate whether it's in the correct format that we want. And we need to parse text files. We need to clean data. And we need to search and extract information. So it's very critical that we know how to handle strings very comfortably. So string manipulation is essential. So let's get into it in more depth. So access individual characters using index. So this is the first thing that we need to know how to do. So every string, okay, and every letter in a string will have a position number. So starting from the first word, okay, the position number, the index, is going to be 0. So the position number doesn't start from 1 because it's in the first position. It starts at 0. We call this zero-based indexing. So you need to remember that it always starts at 0. And Python, it's 0 to index 5. Okay. So if we print, so we access the elements at that specific index with word with square bracket 0. So here, this word is going to be the name of the variable that stores that string. Well, to be exact, strings are not directly stored in the variables, but that is going to be out of the scope of this curriculum, so I'm not going to get into that in details. So here, that will be the name of the string variable, and we use square brackets, and inside the square bracket, we use the index number, and that will bring the value the character saved in that specific index. So word 0 is going to bring P. Word 2 will bring T, so it will print those letters. Okay, index starts at 0, and every letter, every symbol, every number, even space will have index number in a string. All right, and we can also count from the back. So it's like, with the for loops, we with the range function, we started counting from the back, for example. It will be very similar to this, okay? So here, if we use negative index, -1 will be the last letter in a string, okay? And then we go forward, so -2, -3, -4. So as beginners, it's going to be a little bit confusing. Like when we use negative index, we will not use 0 index. Okay, it starts at -1. But when we start from the beginning, okay, it's from the front, then it's 0-based indexing. So we start from 0. So print word -1 again will bring the last letter in a string. Okay, -2, -6. So yeah. Now, we can extract part of a string. So maybe if we have an entire sentence, then maybe we just want to bring some words from that sentence. So that that part of the string, we call it a substring. And we can get that using the syntax here, start and end. Okay, so let's say we have the string hello world, and our variable is text. Okay, so here we can get the letters that we want using the colon here, and the starting index and the end index. Okay, and remember with the range function as well, we said whenever we set a range in computer science, usually the last number, the end index that we designate, is going to be excluded. So we say that it's exclusive range. So here, that 5 is not going to be included in the text that it's going to bring, which means, so this is going to be 0, 1, 2, 3, 4, right? The O is at 4, right? That means we need to set the range here to 5 so that it can bring the substring from 0 to 4, okay? Now, the world, if we want to bring it, so the W is going to be at index 6, right? And we can designate it by using 6 to 11. Again, so the D is at index 10, right? So we need to designate it as index 11 so that we can bring the characters from 6 to 10, okay? Now, that means if we want to bring the entire string, well, there would be no reason to do that when we're taking a substring. But still, if we wanted to bring the entire string as a substring, then we would designate the indices as 0 to 11 so that it can bring the characters from 0 to 10. Okay, so very important. The start is included, but end is not included here. Okay, so 0 to 5 gets indices from 0 to 4, okay? All right, so there are some shortcuts in doing this, though. Okay, so here are some convenient ones. So let's say if we have a text called Python programming, so we can designate the end index only. And what that automatically does is, because this part is empty, Python will automatically recognize this as 0, the start. Okay, so we're only designating the end index here, and that will bring everything from the beginning to index 5. Okay, same thing here. If we only designate the beginning index, the start index, it will bring everything from the start index to the end of the string. Okay, and yeah. There are some cases when we need to bring the entire string, so you don't have to designate anything there. That will just automatically bring the entire string, okay? All right. Now, we have something called the len function, okay? So if we put in the name of the variable, or we can also just put in len Alice, just the text, the string itself, we can still put it in there, and that will give us the length of the string. Okay, so len parentheses and either variable or the string itself, that will give us the length. Okay, so here password secure 123. So if we check len password, it will give us 9. So again, just in case you guys forgot, if we have the number within a string, that means that number is not a numerical value, but it's a text value. Okay. So we can use these like, if len password is less than 8, we can print the password is too short. So yeah, we can use the length when we're validating some input from the user as well. Okay. So len counts all characters, including spaces as well. So space itself is a character. Okay. Now, case conversion methods. So uppercase, lowercase. So like when we're doing the module exercises, I kind of introduced the dot lower, but we said when we're validating user input. Okay. So if we want to take either yes or no as a response, okay, you have to consider always that the actual user, okay, I mean most of the users will write small case yes, okay? But a lot of the times, because the first word can be automatically uppercased, so sometimes we'll get uppercase Y with the lower cases, and we can also receive inputs where every... Okay, everyone, let's move to Big Idea 3. So you had a choice to watch the Python lectures before this, or just get straight into Big Idea 3 from Big Idea 2. If you watched the Python lecture, all of the Python lectures before this, then yeah, this would that would make this a lot easier. So you can kind of tell like what these are. So especially the beginning, a few modules will feel very easy. Okay, but there are some key differences between the major coding languages and the language that's going to appear on the MCQ part of the exam. So we need to pay attention to those, especially with lists. Sometimes there's a big difference with the indexing. So let's get right into 3.1, variables and assignments. So variable is an abstraction inside a program that can hold a value, okay? Because the value it holds can vary throughout the execution of the program. It serves as a placeholder for information that we may not know yet or that needs to be updated, like a score in a game. So imagine a variable like a physical box. A variable is going to be a little bit different from the math variable. So it would be unknown values. But here, think of a variable as a container that will hold certain values. And if we want to switch out the values inside the container, yeah, we can switch it out too, right? So, so the name of the variable would be the label written outside of the box, so what container is it, and the value would be the contents that go inside the box, okay? So you can take the value out to look at it or replace it with a new value. If you replace it, the old value is just simply thrown away and discarded into memory. All right, and the convention, the normal, usual way, so would be to be as descriptive as possible of what the variable is going to be. So they should communicate what the variable represents. So current score, username, level identifier. So these would clearly show you what kind of value that variable container is going to be holding, right? So using poor names like X, N, things, stuff. So these wouldn't be appropriate variable names. So in APCSP MCQ exam, a variable can hold different types of data, including numbers, booleans, and strings. So if this was Java, it would be just simple, the primitive type values that are covered in, well, the basic primitive types. So numbers, booleans, and strings. And a variable is not permanently tied to one type here. Okay, you could store a number in X and then later change it to a string. Okay, Although you wouldn't really want to do that. Like if you create a variable, then it should continue to hold that specific type of the variable throughout. So this is what you get on the MCQ exam. So you'll get two different types of formatting, okay? So one would be text code and one would be block code. But if you kind of take a look at it, it's just simply the difference is text code is put inside different blocks according to the chunk of the code that it belongs to, okay? And each statement will individually be in one box, okay? So the assignment operator here too, like if you've in just regular coding, it's usually the equal sign. There are some languages out there like R for statistical analysis that uses the arrow to assign values. And yeah, that's what the AP CSP exam is going to use. So just don't get confused when you see the arrow, okay? So that would be the case for both text code and block code. And yeah, and this would be assign the value 0 to the variable named score. So when this happens, you know, inside the computer's memory, a box will be created, and this value 0, it will be labeled with the variable named score, and we're going to put inside the value 0, okay? All right, so assignment always flows from right to left. Okay, so the expression on the right will be evaluated first, and the result is placed into the variable on the left. If it's just, without the assignment, just regular expressions, okay, it just follows regular order. Okay, but after all the expression gets evaluated, then it gets assigned to the value. So just think of it this way: the assignment. Okay, think of it as another operation. So that assignment will happen after everything to its right is evaluated. So I mean that makes sense, right? If we have a long expression here, we need that expression to be resolved into a single value for us to save that to the variable, right? So yeah. So after this, val will contain the value 7. And overriding values, so when you assign a value to a variable that already has one, the old value will be lost. It's discarded into memory. So after line 1, so a equals 10 in both text code and block code, a will be 10. And then when we do this, it's reassignment. Okay, so we are reassigning the value to the a variable. So the 10 would be replaced with 20, and the old 10 is just discarded, and it gets lost in the memory. So yeah, and a common pattern is so when we are updating the value of a variable, it's very common to use the variable in the expression. Okay, what it's doing is, think of that as the current initial value saved in count. So we said we're going to do everything on the right first and then do the assignment, right? So we haven't updated it yet. So here on the right, we use the current value saved in the initial value saved in count, okay? We increment it by 1, and then with the result, we save that to the count variable. So again, that's why, although this looks basic, we need to think about the order of the operations being done here, okay? Okay, so retrieve the value of count, add 1, store the result back to count. So that's the process. All right, and again, in programming, like I said, the arrow, you can think of that as an equal sign, but still, it's going to be different from the mathematical equal sign. So math class, the equal sign, so x equals x plus 1, is impossible because that would evaluate to a false statement, right? 0 equals 1. So it's impossible, but in computer science, that is okay. That you need to do that, and it's okay because, again, it's not comparison, it's an assignment operator, okay? So the assignment operator is an action. The equal sign is a statement of fact, so equality. So do not confuse the two, especially also in like Python or Java. Okay, when we're using the single equal sign, remember that that's assignment operator. So do not get these confused. All right, so A lot of the times, although it's going to be slightly more complex than this, but on the MCQ, you'll be asked to trace the values of the variable. So x, you start from 5, so x equals 5, and then y equals 10. And then here, we're reassigning the value here to x. What are we saving to x? The value in y. So what we're going to do is we're going to take that value saved in 10, okay, and then we're just going to copy that variable and then save it to x. So x gets updated to 10, okay? So x and y will be both 10 at the end, okay? And then something like this. You just go down in order, in sequence. So a equals 10, and then b equals 5, okay? And then a gets updated to the initial values of a plus b. So a becomes 15. This gets discarded, okay? And now b will use the updated value of a, okay? Because a was updated here. So here in a is not 10, a is 15, okay? So we're going down in order. So we always have to use the updated values as we go down the code. So that will be, so a will be 15, so that means b will be 15 minus 5, so it will be 10, okay? All right, and there's something called the swap algorithm. So when we're trying to change the value saved in both variables, so if you do it this way, it's actually incorrect. It won't work because, again, because of that sequencing, we'll be using updated values. So if a equals 1 and b equals 2, okay, so let's see what happens. A equals b. So a becomes 2. And then b equals a. So that means b becomes... Okay, everyone, let's go to our Big Idea 5 practice questions. So let's take a look at what kind of questions the exam will ask you. All right, so question 1. Which of the following best defines a computing innovation? So yeah, like I said, they don't straight up ask you for these, but sometimes they do, okay? Sometimes they do. But it's going to involve something like computing innovation, but with like later topics, they usually ask using cases and contexts. But anyways, which of the following best defines a computing innovation? Also, these are like not straight definitions, right? So any electronic device invented after 2000. There is no date limitation of what an innovation is. We said an innovation that includes a computer program as an integral part of its function. Right? So the defining characteristics is the presence of code that processes data, whether it's physical or non-physical. All right. And a social media app designed to connect friends is used to spread misinformation during an election. This is an example of an unintended consequence, right? So the creators intended to connect people, but it was used in a completely different way. So it's an unintended consequence. Which factor contributes most significantly to the digital divide? So the processing speed of modern CPUs, socioeconomic status and geographic location. That was one of the main things that we talked about, right? So it's B. The divide is primarily driven by cost and infrastructure. And you know, these affect the cost and the infrastructure. And what is crowdsourcing? So obtaining input or information from a large number of people via the internet. So that was it, right? So it's A. Crowdsourcing leverages the collective intelligence or labor of the public. All right, and the hiring algorithm is found to reject resumes from women more often than men. What is the most likely cause? So these are the typical types of questions that will appear on the exam. So we have a case like this. So what do you think is wrong? Or what's the source of the problem? Like these types of questions. So the computer has a personal bias against women, a personal bias. The training data used historical hiring records that favored men. And that looks the most likely, right? The algorithm was encrypted. So one of the key skills that you need here is making connections between keywords, okay? So this was about hiring algorithm, so we need to identify that there is a bias here. Okay, first bias. Okay, here encryption. Encryption and bias is not a connected keyword, right? We're not doing encryption because of bias. We're doing encryption to protect against attacks, right? A bias is something that happens due to like data. Okay. Yeah. So this is going to be B. All right, which of the following is personally identifiable information? So a list of public holidays, yep. Social security number, that's the most obvious one, right? And then what is phishing? It's a technique to trick users into revealing personal info via deceptive emails. It can be emails, text message, or like a WhatsApp message, or a DM. Now, which Creative Commons license allows others to use your work, but only for non-profit purposes? We said it was non-commercial, so you need to remember that keyword non-commercial. All right, and what does multi-factor authentication require? Is it two different passwords? No, we said it's knowledge plus something else, right? Possession, so here in this case, at least two evidence types of different categories. And what is key logging? Key logging is recording every keystroke a user makes to steal passwords, right? So again, it's B. And what is the primary benefit of open source software? Open source software, so we need to first think about, wait, what were open source softwares? So we said it's like Linux or Firefox, right? So people have access to the source code and they can inspect. So it's B. In public key encryption, which key is used to decrypt a message sent to you? So in public key encryption, we said public key is shared by everyone, which can be used to lock the message, right? So it's going to be your private key that will be used to decrypt a message. And what does a certificate authority do? They issue digital certificates to verify the identity of the websites. But here, what's important was it checks, it authenticates, it verifies the connection. Okay, it verifies that in the connection there's no signs of anything risky. Okay, but it's not verifying the content on the website. So you're still vulnerable, even if there is that certification, you're still exposed to phishing attempts. So you need to be always careful. And rogue access point, it was unauthorized wireless access point designed to intercept data. And a homework gap, we also talked about it. And gap is, and we said it's one of the most common examples used to describe digital divide, right? So it's B. And using a computer, maybe I went too fast probably. So a digital divide issue where students without home internet cannot complete assignments. So remember, just imagine you have a student who has Wi-Fi at home versus a student who does not. So that student has to go to like public library to access the internet. And like if the library closes, then the student can no longer continue with the homework. Okay. All right, so using a computer program to claim someone else's work as your own is plagiarism. And what is the difference between a virus and a worm? A virus, we said it attaches to other files, and when you download that file, then it starts and open it, then it starts attacking your computer, right? But a worm is a program on its own. Okay, so it will be A. And what is a ransomware? Okay, we said the keyword here would be ransom. So it holds your computer hostage, so your computer's locked, and you will the hacker won't unlock it until they get paid. Okay, so that's ransomware. And then why is aggregated data a privacy concern? It takes up too much space. Combining multiple anonymized data sets can re-identify individuals. So that was it, right? So with those data individually, like your zip code, they won't be able to identify who you are. But when you combine these, then you can be identified. So let's B. Which technology uses satellites to bridge the digital divide in rural areas? So Starlink was one of the examples that we saw, right? All right, which of the following creates the greatest risk to PII? Obviously, it's so obvious, right? Sharing your driver's license photo. And what is the wisdom of the crowd? The idea that large groups can collectively provide accurate information. So the key word here would be the wisdom, okay? Right, and why might an innovator release software under an open source license? Okay, to ensure no one can copy it, to allow others to improve and secure the code, it would be that, right? And which scenario illustrates doxing? So encrypting a hard drive, publishing a user's home address, so that was it, right? So revealing others' PII on the internet, that's called doxing. And why is symmetric encryption considered risky? So we said it's a key distribution problem. So the single key must be shared secretly first. Okay. Yeah. So it means I lock a door. Like I said, you lock a box, you send the box to your friend. How are you going to pass on the key? It might get lost during the way.